Hi, my name is Turansky and I'm a final year student at Middlesex University, and I've created this video as a showcase for my CSD3700 project. For this project we had to come up with some kind of toy or sensor based project that interfaces with a computer, and that was the specific part. It had to interface with a computer. So today I'd like to show you Smart Cube, a digital reimagining on a classic children's toy.
Well done, you've matched a triangle. A triangle has 3 sides. Count with me now. 1, 2, 3.
So when I started thinking about how I was going to build this project, initially I thought I would use a pre-built box. So I started looking online for children's wooden box toys such as this one here, and I couldn't really find anything that gave me the space inside to fit the Arduino and to fit the circuitry I needed. So at that point I thought I'm going to have to make my own box, which is fine. I enjoy making things, so I thought it would be fun. The first step was to plan it out. So I used some pen and paper and I sketched out all the sizes of the parts I need. I wanted to know the rough size to make sure I could fit the circuit board, etc. And I also used the plan to build a cut list so I could go out and buy the right size of wood. So once I had the cut list, it was time to start constructing the box, and I kind of made it like any normal box. Started at the bottom and built up the sides and put in some corner supports. From there I cut out the wooden shapes using a hole cutter for the circle and using a range of saws and jigsaw drills for the other shapes to get the shape we needed. Finally was the painting, and to do that I got some tester pots from Wix and I hung up the shapes and hung up the panels that I could and gave them 2 to 3 coats of paint until they were looking nice. So how does the box work? I wanted to keep it simple. There wasn't any point using depth sensors or light sensors, so I thought I'd use a micro switch. So inside each of the 4 shapes is a micro switch. When the child gets the wooden block and they place it inside, it simply presses the micro switch and keeps it pressed down, which triggers the Arduino to do the next part. For this project, the class was told to each create a sketch using fritzing. Fritzing is a piece of software used to sketch out and model common hobbyist boards such as Raspberry Pis and Arduinos. So as you can see here is the diagram for my working circuitry. You have the Arduino on one side, which is connected to the breadboard via the ground rail. I've connected the ground rail to the top line, which means I can access it multiple times for each switch. Connects on one side and connects to the board using ports 2 to 5 so that I can interface with them and measure the readings. Now let's have a look at the code that makes this project work. If you look at the start here, you can see the serial begin command. This uses the serial library, which allows Arduino and processing to talk together, and the 9600 refers to the data speed it communicates at. Next you can see here we define what pins 2 to 5 do. This is where the switches connect into the Arduino board and allows us to control each switch individually. We also use the pull up command, which allows us to use less resistors in the circuit. The only downside is that it reverses low and high, but that's not a problem here. Next we use the 4 sensor values, the 4 switches, and we put them into an integer, which is read by each of the ports or the pin modes that we spoke about earlier. Further down the code we have an if-else statement, which says if one of the shapes is entered, so say the triangle is entered, it will produce an A. If the diamond is entered, it will produce a B. And when this happens, the LED turns on and it serial writes the letter in question, and that means it pushes it over to processing. At the end of the if-else statement, you can see we have an else clause, which basically produces an E at all times when nothing is entered. This prevents the program sending a null, and null in this case can break the code. Now let's have a look on the right hand side. We have the processing code. At the start you can see we import the libraries, so in this case we use the serial library and we use the minim library, which is an audio library, and below that we declare the 4 images, 1 image for each shape. After that we declare the 4 audio tracks, 1 audio track per shape. Here we take the letter sent, so A, B, C or D, and we store it in a value called val, which then we can reference later on. Here we set up the stage, which is in this case 640 pixels by 480, and this is the square which the shape will be displayed in, or the picture of the shape. Here we load in the audio tracks and the picture tracks. So we have the diamond, the circle, JPEGs, etc. And we have all the shape MP3 tracks, which is the audio which is shown when each shape is entered. Here we have a nested if statement, which takes our val and it checks if the val contains a certain letter. So if the val contains an A, it plays a specific image and a specific audio track. If val contains a B, it plays a different audio track and a different image. This allows us to play different audio and different pictures when each different shape is entered. For easy access while I was building the project, I created this easy access side panel. It's magnetically attached and allows me in seconds to pull the side off. Now I'm sure you want to see the inside, so here we go. On the inside it's relatively simple. We have 4 micro switches and the cables coming off them. That attaches to a miniature breadboard and the Arduino itself.